Greetings, Aja. Now that we've discussed choosing a model and embeddings, what's our next topic in the series?
I thought it would be good to dig into RAG so we can see why people create embeddings in the first place and how you can help the LLM you selected generate better results.
So for all of you following along, RAG is essentially retrieval augmented generation. So it's augmenting generation with something you retrieve. And cut.
No. Okay, hopefully we can go into more detail and break down the jargon and give folks tips for creating straightforward RAG applications.
That's fair. So first off, what exactly is RAG and what's the purpose of it?
RAG is just an architectural approach to building AI applications and services.
So RAG is just a common AI architecture in the same way the three-tier app is a common web architecture, right?
Yep.
And the goal of RAG is to improve what the LLM generates by grounding it in data that's relevant and known to be accurate.
Exactly. And now that we've established why we would use RAG and what it is, let's dig into the data flow of a typical RAG application.
This is probably going to be easier if we have an example, right?
Yeah.
So let's say that we're building something for maybe a local government website. What we're going to do is help people find information about various things that are going on, like jury duty or maybe even pet licensing.
Okay. So to start with, RAG apps have a pre-processing step where you need to create the embeddings for the data you want to use for grounding your responses. Our videos on embeddings can help you understand the options here and the things you need to consider.
Okay. And for this chatbot, we'd probably want to chunk and create embeddings for all maybe the different pages on our website, and maybe even for additional things like forms and brochures or images that we have. And we should store all that data with their embeddings in a vector database.
Okay. So with that pre-processing step out of the way, let's walk through what happens when a user asks our chatbot a question. First, we're going to take the user's question, and we're going to call that a prompt, and we're going to use the same embedding model we used in our pre-processing step to generate an embedding or a vector of that user's question. Then we're going to use that embedding we just generated to find some number of related pieces of data in our data store using a similarity algorithm.
And I think we talked about this in our embedding videos, but just to recap, we use the embeddings model to make sure that all of the similar data ends up with similar vectors. And that makes it easy for a vector database to find all the related info.
Exactly. Now, once we've found that related info, we're going to add it to the original prompt, augmenting what the user gave us. That's the A in RAG. Usually you'll also add some text to tell the LLM what to do with that related data. For example, base your answer to the user's question on the following documents.
Just to clarify, since it confuses folks, when we retrieve the related data, are we retrieving the actual vector or the embedding, or are we retrieving the original piece of data that we made the embedding off of?
Great question. This confuses a lot of people. You use the embedding, the big array of numbers, to find similar pieces of data, but the vector database returns the original data in the original format. So that might be text or a photo or video or audio.
I think that makes sense. And so then the original human readable data that we got is what we're going to add to our LLM and give that to the LLM in order to help generate its answer.
Yep. So back to our walkthrough. Once we've added the relevant data or context to our prompt, we can send it to an LLM like Gemini.
Does that have to be the same model that we used, though, when we generated our embeddings?
No, as we talked about in the embedding videos, it doesn't have to be, and in many cases it won't be.
So then what do we do with what Gemini generates and returns to us if Gemini was our LLM in this example?
In the simplest case, we just pass Gemini's response to the user, since Gemini's response should contain an answer to the question the user asked.
Okay. So let's make sure I can summarize this right. We generated embeddings with all of our data. Then when our user asked a question, I think a few things happened. First, we generated an embedding of what the user's question was. Second, we used that embedding to find relevant data in our vector database. Third, we took all of that relevant data and we added that to the prompt that we sent to the LLM to get a response. And then last, or fourth, we sent that response back to our user with the answer.
Yep, that's it. That is the data flow for the most basic RAG application.
Okay, but let's say I'm not happy with the very simple path, which I should be, right? What are some of the common mistakes that people make, or what are some of the common things I can do to improve my RAG performance?
So first part, the embeddings are the heart of a RAG system. If your embeddings aren't appropriate for your data, you won't be able to retrieve relevant data for the LLM to use to generate a response.
So I think here, right, it's really about the concepts of embedding dimensionality, maybe the chunk size and the chunk overlap of my embeddings. Those things are really important to thinking about how I get the most performance out of the data that I give RAG.
Another thing to think about is the quality of the user's initial question. Since we're creating an embedding vector from that, if the quality of the question is poorly formed or has a lot of misspellings, that may impact the quality of the results. Some folks have had good luck with sending that initial question, that initial prompt, to an LLM and asking the LLM to improve it before they proceed with the normal RAG workflow.
That's cool. And I also think, as I think through these things, what data I'm going to put in the vector database at first also could change the results that I get back. So I may want to have folks actually write up specific answers to common questions and put those into the database so that way I get the highest quality response back.
Exactly. And you can also try varying the number of relevant pieces of data you return from the database that you put into your call to the LLM. With today's large context windows, it usually makes sense to include more relevant data, but you should check how changing the amount of information you add changes the quality of the responses.
That's interesting. I think 2 million context token windows probably comes into play here in some sense. Okay, so we've talked about how we can do all these cool things with RAG. We've explained how it works, and obviously we've done a quick walkthrough. By the way, we have a code lab and a jumpstart solution you could deploy to try RAG out, and the details are in the comments below. With that, this is Aja and Jason with Real Terms for AI. Happy prompting, everyone.